Hey guys, welcome back to my series on restoring classic late 40s American black and white electrostatic televisions. In this series I'm going to be pointing out some of the differences between these sets and the more common magnetically deflected sets, give you some tips, some tricks, some suggestions, some pitfalls to avoid to get these up and running. Okay, we got our chassis up on the workbench. We took a look underneath, didn't see anything that concerned us. We can move on. Now what would have been concerning, well, parts missing, things that were clipped out and we had wires hanging, or if rodents had chewed on the wires, or if there was heavy corrosion, or if there was charring, melted parts, parts that had gone up in smoke, electrolytic caps that had blown their guts out. We didn't see any of that. Just some tidy old repairs. I next went ahead and pulled the tubes out and tested them. If you have the luxury of a tube tester, go ahead and test them. These were all fine. And that's pretty typical, as I mentioned in the earlier installment, that a lot of these sets were just retired because the picture tubes got tired or they got a better set. The one that you should really focus on, though, is the rectifier. In this case, it's a 5Y3. Why? Because people like to plug things in and turn them on. And I mean in more recent times. And often the filter caps have gone bad with age or use. You plug it in, you turn it on. These have gotten very leaky. It puts a really excessive load on the rectifier tube. I've seen some of these so bad with holes burned through the plate or the glass melted. But this time it checked okay. So it's pretty likely that no one has plugged this in a very, very long time. Now, we could put all these tubes back in and turn it on with a dim bulb or a variac and slowly ramp it up. I'm not going to do that though, because experience tells me that it rarely produces anything all that useful. Now, I've done it plenty of times with magnetically deflected sets, but these, because of those high voltage caps that are almost always bad, they're going to kill the high voltage. You're not going to see anything on the screen. You might get a crack a lot of the speaker though. I'm not saying you can't do it or you shouldn't do it. I'm saying don't expect to see anything all that interesting if you do. Could I reform this cap? You know what? I'm not going to bother. It's the only cap in this. Yeah, I mean the only chassis mount multi-suction cap. There is a 2-suction cap underneath, and there's a single axial electrolytic in the sound circuit, but this is it. We have one cap to contend with. So I'm just going to replace it. If you want to restuff it, use an adapter cap, whatever. We'll talk more about that in a moment. So I tested all these tubes. What I didn't test is the picture tube. As I mentioned earlier, very few testers list this in the setup chart. And I don't think any actually have the right socket to put on it. It's a big old 14-pin base on this thing. Not your standard little 12-inch base like you'd see on a magnetically deflected picture tube of the same era. So what can we do? We can certainly check for continuity on the filaments. Let me flip this around. I'll show you what the base looks like. This. It's pretty hefty. We got a lot of pins on there, but they aren't all used. Now, I will warn you, these are very, very, very often loose. And I don't mean this, I mean the base on the CRT, because there's so many pins. I've seen these damaged so many times where we pull this off and it rips the base right off. Or it pulls the pins right out of the 14-pin base. Be very ginger when you take this off, which I'm going to do right now. Pry it off. Don't pull it off. I'm going to use a pocket knife. There's a little bit of a crack already here. I'm going to work it in there and slowly work my way around to pry this off. So we can use an ohm meter to check for continuity on the filament pins. Now this is a parallel wired set with a power transformer. Very unlikely for the filament to be open. That came off much more easily than they usually do. I got lucky. Again, these Admirals are a little bit higher end, higher quality, so the socket's a little bit better. So I think that's why it came off more easily. But also often these are very loose. The bonding between this and the glass has gone bad. But again, in this case, it's a slight wiggle to it. Now another thing you might want to do is check the getter to see if air is leaked in. We can't see it. Why? Well, another thing that's unique to this type of set is they have a shield on it very often, running from here to here. That's what this metal is with the spring clip on it. Electrostatic sets are very sensitive to magnetic fields. So, if without this, straight magnetic fields, like the power transformer, could induce ripple into it. Notice this is mounted at a 45-degree angle. Well, that's why, it's to minimize that effect. The earliest version of this chassis had it mounted, as you would typically see, at 90 degrees. They determined early on that that was, even with the shield in place, still radiating some interference. They rotated at 45 to minimize that. That's also why this is here. But it also means we can't see anything. We can't see the getter. But I see few, I don't know if I've ever seen one of these that's actually lost its vacuum seal. So that I'm not too concerned about. So what are we going to do? Well, I mean, you could invest the time and effort into restoring this enough that you would get an image, which would mean replacing those high voltage caps, maybe the electrolytics of the power supply, maybe the caps on the high voltage oscillator circuit. We'll take a look at it in a bit to see if it's good, or connect a working set. Well, one nice thing about these is if you had a working chassis, there's usually enough play on these. If I put them back to back, I could leave this mounted on the chassis and plug it into another set and see if it was good. Now, I have the luxury of having a Sencor CR70, which is a universal adapter. It's a little alligator clippy thing, or J-hook clips, and I can clip it onto here. And they do list the 7JP4 and old copies of this. So we are going to test it. And if it's a decent, fairly strong picture tube, or has some life left, you will actually get a splotch on the front of it, about yay big. If you have to dim the lights to see it, but even with just a few hundred volts that the tester puts out, far less than normal 5,000 or 6,000 volts these run on, it will still produce an illumination on the front. So we'll get to that. Well, something else I want to do, which has nothing to do with it actually working, is clean this a little bit, because it's pretty gross. Not just the metal chassis, but the face of the CRT and all that this is nasty, nasty. I have found CLR just straight, applied with a brush and wiped off, does wonders on these metal chassis, and we'll just use Windex on the 7JP4. I'm going to do that right now because, well, it means that my hands won't get filthy while working on it. I won't be so concerned that I'd want to wear gloves to protect myself from these contaminations. It's just more pleasant to work with. I won't get dirt on my workbench. So let's do that next. Now be careful when you move these chassis around. The metal isn't that thick. You've got a heavy transformer here. It's warping. The picture tube is mounted right to this. I don't want to stress it and crack it. So grab it where it's firm and sturdy and gently move it around. Set it down. So let's do this first. By this I mean picture tube, Windex, paper towels. Make a quick work of this. Same with all the tubes. All the tubes are pretty nasty too. Not to be Windex, just your glass cleaner of choice. You can just use some ammonia and vinegar and water if you so prefer. And, yeah, very easy to clean, makes a big difference. And also look for defects. Sometimes there's little air bubbles in the glass. That was just acceptable back then. See, there's a little one there. Actually, no, it's a little bump in the glass. I believe these were molded in two halves and kind of welded together, or melted together. Yeah, I can feel there's a seam running right along there, and one on the other side. So this is made in two halves that were put together. It's in terms of the body, and the front was a separate piece, and there's a weld going around the front. So these are made out of 3 pieces of glass. Don't know if any video exists of the process, but it'd be kind of cool to see if there was. I don't know exactly how they attach the pieces together so well that they could withstand atmospheric pressure. Alright, that made a big difference. Let's try cleaning up this little area here on the metal. I'll talk more about tools I suggest you get in a little bit, but for now I'm going to mention, get yourself a bag of cheap brushes, assortment of brushes to your local Michaels or Hobby Lobby, or jump onto Amazon. A few bucks, get yourself a few dozen of these little brushes that come in handy for getting debris out of the way. See, a lot of this is just coming off already. It's just a lot of dust. I believe this set came from Texas, so I think this one got just a lot of desert grime on this guy here. It's not so much corrosion or baked on or nicotine, it's just dirt. Alright, so I'm just going to use CLR straight out of this. Could dilute it a bit, but just use it straight. I'm going to brush it on, let it sit for a few moments, and then remove it. You can see it's doing its thing. Sometimes it takes 2 passes. It's especially dirty. Look at that. Beautiful. Once it's pretty clean, also, you can, instead of brushing it on, just apply a rag or a paper towel. Give it a good wipe down. And after this, I'd suggest you do a wipe down with just some clean water, distilled water, or Windex, Simple Green, something like that, to remove any traces of the CLR. So I believe it's slightly acidic, and I don't know what that might do to this metal over time if you left it on there. Pardon my wires. This is a Suncor CR70. Now, I do not expect any of you to go out and buy one if you don't already have one. They're a bit expensive. They're not that easy to come by. They're popular with a lot of restorers because they can do everything from the earliest picture tubes to the most modern and everything in between. And part of the reason is they have this universal adapter, which has a bunch of clips coming out the end, clip onto the CRT, and they have a special setting for scope. Most do not. Could you take a regular tester, like say a cheapo common B&K 440, and make an adapter and test with this? Yeah, but you may want to tinker with the bias. This just adds 10 more volts negative than the most negative bias setting to it, so it's not anything all that special. I'm sure you could make your own tester with a variable power supply and tinker around with the voltages. You can look up the data sheet. And remember this, 114,239. Pins 1 and 14 are the filament, 2 is the cathode, 3 is the first grid, and 9 is the second grid. That's what I have these clips going to. So let's fire it up. We want 6.3 volts on the filament. So the first thing we're going to do when we turn this on, just do the filament set. So we did 6.3. Ideally, we would look for glow on the CRT, but we can't because it's covered in a shield. So we're just going to go off the meter reading. We're going to let it warm up a bit. Let's flip over to HK shorts. Green is good, so I don't have a heater cathode short. Check for a grid short. Don't have a grid short. I don't know that I've ever did. I think once I found a grid short in one of these. As I say, they usually test okay, but it's really what kind of image can we get? We don't have cutoff control. Do we have emissions? We do have emissions. Or we did. It doesn't mean it's bad. Now, these clips stink. I should really make a dedicated adapter with a spare socket. So let me make sure that everything's... You notice the reading's changing. I did not have a good connection. These are a little finicky to test because of all those pins and all these connections. And emissions are responding to cutoff. Now if I go back to the cutoff, yeah, we have cutoff control. Set that in the black box. Check emissions, they're good. That doesn't mean anything to me. I mean, it means it's not dead. It means we do have vacuum, but they're just about all test like this. And we can check the emissions life test. Absolutely rock solid. Still don't know if it's actually going to produce a good image or not until we completely get this working. But let's see if we can see a splotch on the front. Huh, yes we can. Good. I will dim the lights and show you. Well, it's not going to be very bright, but if I block the light here, there we go. There's our splotch. So, we're fine. We're fine. And I don't want to discourage you guys. I just want to set your expectations to be realistic. I've only encountered out of maybe 50 plus of these I've worked on, like one that could not produce an image. I've seen plenty of dim. I have never seen one that was super bright. But most produce a so-so acceptable for demo purposes type picture. And I also suspect most folks that's good enough. I don't think most people are masochistic enough to want to sit down and watch a feature-length movie on one of these. I certainly never have. I've never even watched an entire half-hour program on this. I fire them up for demonstration purposes, challenge my technical skills, restore them for other folks. I don't watch TV every day on these things. I think they're cool. I think they're interesting, both historically and technically. They're fun to work on. They're fun to get working. I don't sit and watch one all day. So, if it can produce any halfway decent image that has good focus and definition, that's a win. So I've mentioned a few times that these don't have a flyback, but I've also mentioned a few times thousands of volts. Where's that coming from? There's one set, early set, I think the Focal 48700, that produces it from here, like a neon sign transformer. They have a high voltage winding. You want to call it a Widowmaker, okay. Yeah, it's right off the power transformer. They have a winding that kicks out thousands of volts with a decent amount of current, lethal potentially. Most sets, basically every other set, certainly post-war set, aside from the Philco, uses what's in here, which is sort of like a mini Tesla coil. It's a step-up transformer, and it's driven by a 6V6 tube that would sit in the socket as a feedback oscillator. Very common for these screws to be missing. There should be a whole bunch of screws all around the bottom and one on top. I see one around the bottom. And that's it. There's only one screw left on the bottom and one on the top. You should really put them all in there because this produces a ton of hash noise from the crude oscillator, the feedback oscillator. It's just tons of harmonics. So you really want to get a good RF shield around this. Beautiful. Motorola sets use, I think, an identical coil, or one that looks very similar. Notice this has copper on the inside. These are well made. Most of these electrostatic sets won't have something quite this nice. It'll just be an aluminum box with holes around the bottom. These copper clips, I think, might be unique to these Admiral sets. So what are we looking at? So, coil. We have a couple pancakes. I think 2 of them here. Some have more. This has many turns. That's your secondary. Down below we have 2 windings. The inner one, it's heavier gauge wire. That's your primary. And there's a couple turns of heavy gauge wire. That's filament supply for this tube. So this is a 1 volt rectifier tube, a 1B3. All the rest of the tubes are 6.3 volts driven off the power transformer. This gets its filament power from this, and this oscillates because of this. So we also have this guy, which is a feedback loop. So there's some capacitors and resistors on here. It forms an oscillator, tank oscillator kind of thing, and this provides feedback. That's unique to the sets that use this type of coil. And there's a clip on here around this tube, and you can move this, and you position this to get the best output voltage. It's like an efficiency adjustment. Kind of a crazy thing, but it does actually work. So this provides your positive feedback to keep the oscillator going. These are usually good, and they usually don't. There's nothing you need to do in here except maybe replace this tube. Don't mess with this stuff. Some very fine wires. You don't want to break them. If it's a little bit of dust on there, who cares? It's fine. Just maybe blow it off. We're done. I don't see myself needing to do anything else inside here. That is the original tube. It's got a 1949 date code. These usually last a long time, and considering these are usually fairly low hour sets, it's probably fine. So I'm just going to put this cover right back on. Too much chance of something breaking. It's a ceramic core, very fine wires. So that screw up top, it goes into that rod going down that coil, ceramic. Don't crank down on this screw or you can shatter that ceramic tube. It's an internally threaded ceramic tube, and there's another screw on the bottom that's holding it down. Just make it snug. That's it. And we should really replace all these screws, but I'll just put the one back in for now. They're just little self-tapping sheet metal screws. All right, now what?